And we're live with 8.4 part 2. Alright. We're looking at polar equations and rectangular equations. So yesterday we practiced first plotting polar points. Then we practiced converting from rectangular points to polar points. Then we practiced converting from polar to rectangular. Now we're going to look at writing the equations of a polar graph, and then writing the equations of rectangular graphs, okay? All of these pieces of information right here from the formula sheet is the same. There's nothing new up here. I am going to bring this back up and just erase this, ignore this. Alright, so that way you can see what to write right there. So, it says convert each of the following to a polar equation. That would mean it's starting out as a rectangular equation, which is something we are already used to, and we are converting it to polar form. Since we're going to polar, that means we need to be in terms of like r and theta. So keep that in the back of your mind. Polar means r and theta. Rectangular means x and y. You've got this up here, which will be given to you. You just have to know when to use it. Look at your green formula sheet so you can go ahead and start training your eyes where to look, like to get this info. Because that's the exact same formula sheet you're going to have for the test. We simply replace x with r cosine theta, and we replace y with r sine theta. In this particular case, we don't know what theta is, and we are not trying to find it. We are just trying to sub in and clean it up. That's all we're trying to do, okay? So don't try to figure out what theta is. So let's go over here. We have x squared plus y squared equals 25. X is actually r cosine theta, copy the squared. Y is actually r sine theta, copy the squared, equals 25. Alright, so that's it. That's the answer, but that is not in what's called simplified form. We do have to clean it up. So let's evaluate the squares. Be careful. There are two things here. There's an r and a cosine theta. So this would be r squared cosine squared theta, which looks really ugly, but that's what you would get when you clean up that squared. Same thing here. This would be r squared sine squared theta equals 25. Just a nice little reminder, don't square the theta. Theta doesn't change. It's the trig function that you write the squared. Alright, here's where some of y'all might take your shoe off and throw it at me, but that's okay. I'm prepared to dodge it like George Bush. Alright, what do you notice they both have? Don't throw anything.
Which one do you want?
There it is. I knew it was coming.
Well, you want one?
Might as well, yep, just everybody, I'm going to let y'all all have.
Who wants a ball?
That one could just go to 8.
Everybody else want one? Here you go.
Anybody over here want one? Y'all can throw it at me. Anybody?
Anybody want one?
Sure.
Anybody want a house?
Will. She's already made it clear.
Anybody want to throw a house at her?
Throw a house at me?
I guess I'm just going to get everything in here that I technically can throw.
Throw the house.
Okay, there's the house.
Just don't throw the tennis ball.
I don't know where the tennis ball is, so.
Alright.
Luke, you want to throw something at her?
Y'all ready?
Luke, you want to throw something at her?
You're about to chunk that up.
Do we have to factor out?
What do you notice they both have?
R squared.
They both have an r squared. we're going to factor in r squared to the front. You're not going to throw them yet. This is not a big deal.
Or you want to throw it though?
Don't throw it yet. We're going to factor in r squared to the front.
Because cosine squared plus sine squared equals 1.
Yay!
So it's literally just r squared
It's
equals
r squared
25.
equals
So r equals 5.
So r equals 5. So if you remember cosine squared plus sine, I know, see?
I did that. Wait, where's that supposed to throw that in?
Right here, where we have to call back on chapter 7. Remember cosine?
Is this always
Yep. Cosine squared plus sine squared is actually 1. So this is really, this whole thing is actually 1. So this is really r squared equals 25 square root. R is 5.
So now
Is that the only thing we got to go back and find, or do we have to? Is there more?
Okay, hold on.
Hellcat
What?
release chest.
That is a polar equation. That's what's so weird about polar equations is they look weird. Yeah, you can throw it at me. Here, I got it. This is the polar equation. R equals 5. It looks like you really just found the length of R, but that is the polar equation. So I would like you to draw an arrow, and I would like you to write, this is the polar equation, because when you look at it, you think you've just found the length of R, but what you really have found was the polar equation. And what I was anticipating you not being happy about was the fact that the identity from chapter 7.
I mean, as long as we just have to use that one.
Yeah, is there more? So that's when the balls get thrown.
That one. Yeah, I think that's it.
Really? Oh, that's light work.
That one could have hurt.
Yeah, that one was fast.
There was something personal behind that one. He threw the brain. Like, of all the things, he threw the brain. All right, let's do the next one. Now, here's where you're going to see that the polar. So in this case, the polar equation. Look at the difference. Here, the polar equation is actually cleaner than the rectangular equation. Although we all prefer the rectangular because we're so used to x and y. But what I mean by cleaner is, I mean it's short, sweet, to the point. It's r equals 5. Let's do the next one. Here's where you're going to see that the polar equation is not cleaner, and in this case, you would just want to come back to the rectangular. So plug in r cosine theta and r sine theta in for x and y. You with me? Okay, what do you notice they both have? They both have an R. Let's pull the R to the front and see what we end up with. Do you see, like, anywhere we can go? Yeah, not really. So, in this case, we're just going to say, okay, that's enough. We're done. This is getting, we're just moving a mess to a corner, and then it's still a mess. But we're going to make a note. This is the polar, I'm going to put EQ for equation, which is not as clean. And what I'm implying is it's not as clean as the equation it started at. It was 2x minus y equals 5. That's a much nicer equation than 2 Then r parentheses 2 cosine theta minus sine theta equals 5. That's not as nice. Okay, so the takeaway here is to go from rectangular to polar, you just plug in r cosine theta, r sine theta, and you just kind of clean it up. Now we're going to go in reverse. Reverse. Okay. Yes, you need to shave one more time before prom.
No, I can't.
Oh.
Oh Lord,
Also,
don't.
if you're wearing a dress, it's going to make you cry.
That's true. Nobody's gonna be able to see.
Oh, well, wait.
Oh, you have a
I
slit.
wouldn't say
How many
nobody.
times is your leg going to come through
Let's not listen.
It's probably best if you're not
Good answer,
listening.
Luke. Good answer.
I literally had music.
I'm just saying, I wouldn't dress like that because I don't.
No, you're not.
I mean, this is like
But when it's 5 degrees in here, still my leg hair's growing.
Listen, it is better to be cold in here. It's better to be cold in here.
Hey, Miss Holcombe.
Because when it's not cold, it stinks.
I didn't throw it that hard.
That was personal.
Do it.
Much almost here.
Do it.
Yeah, do it. I got it.
Glass.
You think I can't catch it?
How did you go your leg?
Miss Holcombe, catch!
Stop! Oh my
Miss
God.
Holcombe,
Okay,
that's
I'm
exactly what I thought.
I'm done. I've learned my lesson. I've learned my lesson. Don't you dare.
Yes,
I've
ma'am.
learned my
I
lesson.
can't catch.
I can catch. I'm just never gonna go that all out. All right.
That was pitiful.
Sorry. All right. Go to the next slide.
Alright. Now what?
Say that again.
Okay. Now what we're doing is we're going from rectangular. We're going from rectangular to. I'm sorry. We're going from polar to rectangular. Notice it says convert to rectangular. This means your answer.
So, like, is this like actually what engineers use? Yeah, use all these.
I'm not sure exactly what field would, but I can look into that because it does kind of interesting.
Yeah, I mean, because, like,
But my goal might be involved in like architecture that has round, possibly, maybe. Yeah, I'll look it up because I'm curious. Okay. All right, so we're going from polar to rectangular, and this is where sometimes it's a little more challenging because, shh, y'all listen. Sometimes it's a little more challenging because it's not the same approach on every problem, and that's kind of annoying. Like if you go back to the last slide, it was the same approach every time. That's not the case here because it depends on what we're working with. Like in A, we only have R, but in B, we have R cosine theta. Those are totally different approaches. So it's going to come down to, it's a puzzle, and you're using your formula sheet, I'm just pointing like in general down here. You're substituting, I'm going to write X, Y stuff in, and to clean it up, okay? So like A says R equals 4. Well, that would be my clue to go to the formula sheet and see what does R mean. What is R in the formula sheet? R is,
X squared plus Y squared under a square root.
yeah, so we're gonna write, what is that? So we're gonna write formula,
Oh, I help you so bad.
R is the square root of X squared plus Y squared. We're gonna pull that So now where there's an R, I'm going to write the square root x squared plus y squared equals 4.
Yeah, and I'm trying to listen.
Yeah.
Is he actually singing? Oh,
What?
I just thought he was doing this. I can't hear him.
Luke doesn't
All right.
know what he said.
So I've plugged in the square root of x squared plus y squared into R. And then now this is the answer, but we do need to clean it up. How can I get rid of this gigantic square root? I
Square
can
it.
square both sides. So I like to draw the squaring of both sides by this is me. You may not want to do that. You may want to do it individually. It's up to you. I'll draw it individually. How's this? There you go. So square both sides. Whatever you do to one, you do to the other. That's going to cancel. I end up with x squared plus y squared equals 16. And that looks good. This is where it's kind of annoying because you just stop where it's like, you know what, I don't need to go any further. I like that. That looks like a regular equation that I worked with in the past. So that is our rectangular equation. We do need to make a small note here, and it's all because of the fact that we just squared both sides. All right, so I'm going to draw an asterisk here. This is just the math nerd in me saying, hey, be careful when you do this. All right, here's what we're going to write. Be careful not to introduce solutions that were not already present. I'll explain it in a second, just write it. Okay, so be careful not to introduce solutions that were already present, that were not already present when you square both sides. Write it and then I'll explain what it means.
Ooh.
All right, here's what it means, and this is just the math nerd in me wanting you to understand like where you got to be careful. We started with a square root graph, right, or equation. Let's pretend like it was simple. It was just the square root of x. Let's pretend like it was that. Let's don't focus on the x squared plus y. Let's don't focus on that. Okay, so I want you to think back to the mother function for the square root of x. The square root of x was right here, and it went like that, right? Okay, that's f of x. Need another color. Okay, then we squared both sides, and now we no longer have a square root function. Now we have an x squared function in there with y squared, albeit. So think of what an x squared graph looks like. You got the mother function for x squared, and it's here, right? Okay. Now think of in terms of solutions to a graph. Solutions means where does the left side match the right side on the graph? Where do they cross? Now don't think of where these cross each other. Think of in terms of, you see this purple graph? And if I was looking at where does it cross 4, because 4 was the right side, imagine. Then 4 would be like right here, and it's going to cross in one place, right? Okay, now go to the x squared graph. Do you notice how I have basically 2 halves of my curve, which means I have the potential to cross in more places. So by taking the square root, which was only half a curve, and squaring it, you've just changed the dynamics of the graph that now you've just introduced the possibility of more solutions that shouldn't have been there to begin with. Because we went from a small half graph to now a bigger whole curve. Okay? We don't actually introduce any solutions here because we're not solving. But that was to say, if we were actually solving, you would have to be careful and say, we may come to an answer algebraically, but we'd have to throw it out because we squared both sides, which allowed that answer to appear, but we have to remember what we came from the beginning. That answer would have never come into the picture had we not squared both sides. All right, that's just me getting conceptual math nerd. Okay, do you actually have to worry about it? Not really. Not here. Let's do this one. R cosine theta equals 6. I would not jump in there and replace R with the square root of x squared plus y squared. Because you actually have
Isn't it like R
R
times?
cosine theta right there, which is x. So this is what I meant when I said that you have to be careful when you do these problems because sometimes you approach them in a different manner. And that is so simple, you may want to make a note to yourself where the x came from, but that's it. Like, that would be the rectangular equation. That would be the rectangular equation, and in that case, that's actually just a vertical line. I said you don't need a calculator, you do for the last part. So you do need a calculator real quick on this last part, and we're actually almost done. This is showing you just how to graph them in the calculator. It's kind of neat. You do have to change the mode to polar mode.
How do I do that?
Mode.
Seems
Polar.
chill.
Hold on one second. Let me pull mine up. My foot is.
Mode.
Bless
That's
you.
you.
And degree and then polar? Or, yeah, degree.
Hold on. Like, can't concentrate. Because my foot's like, hey, you want to go this way?
Is your foot numb?
No, it's cramping. 3 of my toes are going. All right. Go to mode. Where's polar? Right. Oh, under where it says function. Notice underneath where we usually go to radian and degree. You can leave it in degree. Go down. Go over. And tell it you want polar mode. It is going to change the y equals. Because remember, polar doesn't have y. Polar has r and theta. So it's going to change it. It's not going to really be y equals anymore. It's going to be r equals. So if we hit the y equals button, now you're going to see r equals. So let me change the notes page. Whoops, too far. All right. We have graph r equals 1 minus sine theta. You're going to set the calculator to polar mode. So just like y has to be by itself, r has to be by itself. I'll let you write that down. In this case, r is already by itself. So I can just go straight to r equals and type 1 minus sine. The theta button on your calculator is the same as the x button. Like when you would push the button to type X. And then you'll hit zoom 6. Is it zoom 6 or is it zoom polar? Hold on, let me look. I'll go back. Sine theta. Zoom.
On mode, under where degree is.
How do you zoom?
Oh, I see now.
Would it be true?
I put it in degree or radian.
It is not zoom.
Degree.
Zoom Zoom 6.
Oh, okay.
Where's the point?
All right, let me lower that so you can finish writing. There are only 2 of these on the homework. My math lab definitely had like 7
Ew.
or 6 or something, and I mean, you're just typing it in, so I was like, all right, that's a little excessive. Let's practice 2 and move on. I feel like the algebra is more important. The paragraph is me reminding you just how to type it in. It's also reminding me how to type it in because the only time I am graphing polar equations is in this section once a year. No, on my math lab, it'll be multiple choice. It'll say match the graph.
This is
Yeah.
last year they're making help guys do too.
Y equals is how you get to where you type it in. You don't type the R. The R equals is just like the Y equals. That's, you don't type that. You type the right side. Yeah, and that's the X button. Like the normal, you know, like if you were typing X squared plus Y, or X squared.
Oh, and you call that mode of just data?
Yeah.
Oh, okay, good.
Yeah, it's the same button you always use to type X, but now it'll produce a theta. So did you find it?
How do I zoom?
Zoom 6.
I'm here?
No, we're here.
No, not second. Like that, but I went to, that was good. Okay, now, just press it.
All right, let's go to the next one.
Mine has nothing.
Zoom 6. Yeah. I know it looks like a dot if you, it does.
Wait, so how do I do?
No, nothing. Did you put it in, did you type it right?
Challenger for 48.
Might as well go for the Camaro for 60.
I don't know how I would do that.
What's your uncrusty right there?
I don't know. The Holcombe a 48.
What cylinder?
8
Oh,
to 6.2.
no way she didn't.
Red outside, black interior. Only 16,000 miles. 8-speed auto. Shit, this thing's nice.
Oh.
Here, question about graduation.
Yeah. Okay. Try that one. All right, y'all try this one.
I did.
This one is practicing changing the window. Changing the window.
Oh, it's so much work.
Notice we're graphing R equals 4 sine 3 theta. There you go. But this time it says, let's change the window. Notice that they do give you, if you're in radians, you know, you would enter it obviously by radians. If you're in degrees, you would enter it by degrees. Yes, so it'll say either in the directions or it'll say up underneath and it'll say use the following viewing window. And it'll let you know. It's crazy, I know.
Window.
Got you infinity.
So you'll change the window, viewing window from 0 to 360, and it's going to go by 1.
Looks like something I can die in.
The window.
To the wall!
Oh wait, I think I missed it.
Okay, I'm recording one.
I stopped myself.
It didn't really change anything.
I hope so. They put it at Heritage.
Window.
Well, it wasn't good. Nobody did anything. I did at one point see somebody's head on the floor and the feet in the air. That was weird. I'm gonna stop myself
We're recording.
I know.
When you change the window,
Yeah.
make sure you don't
I saw-
accidentally hit Zoom 6 after, because now you've just gone back to the other window. Oh, yeah, I would just.
I wasn't gonna do that.
I
I was
like the
gonna
way
do
you draw
that.
His hair.
Yeah,
So do I do
it's-
Zoom 6 every
I was
time?
gonna do
No,
that.
Zoom
I almost
6
did
is only if there's no
that's the
window
whole thing.
requirements.
Okay, now how do I change it?
Window, the button at the top.
Do I do it after I'm done?
Yours is better.
What you're talking about?
Whatever mode you're in. Now, if they give you the window requirements and it's not in both, then you might want to change to the mode they give
It's
it
too
to.
high.
Are you in Radiant?
Oh, I was.
Yeah, I said like put in the radiant oil
Oh.
What are you drawing, butterfly?
Fidget spinner.
But like, or like this, because I
Just
like
the-
Oh, I'm in degree. Am I supposed to be a radiant?
Yeah.
It doesn't matter what mode you're in.
Eyeball.
Yeah.
She's on darker.
You're gonna type the one you're in.
I still got it.
Oh, ground ball.
My only question would be,
You filled a ground ball, I didn't mean to do that.
I'm trying to teach.
Whoa!
I'm trying to teach Reese to put his hand.
Now get a chance.
Yeah, because right now he's just like this, and the ball's going. I'm like, dude, you're fixing to get it right in the chin.
Yeah, it's gonna pop up and
Oh.
bonk him in the nose.
So they're talking about 30.
Where's my?
It's
All right.
purple though.
So
what?
the point of that one was to teach you the viewing window. The point of this one is to teach you R needs to be by itself before you can go to the calculator. So in this case, I would subtract the 1 over, and those are not like terms. It would be R equals 2 cosine 2 theta minus 1. Oh, I wrote it right there, sorry. R has to be by itself. And then you would go and graph it. And they don't give us any restrictions on the viewing window, so we would hit Zoom 6 to be able to see it. Again, you're going to have two of these. You're going to have two of these in your homework. Do this. Just draw a really big 8. Draw an 8, and then come over here and draw a second 8. Ooh, that was bad.
An infinity sign?
Reminds me of those wooden spoons they give you for those ice cream cups.
I don't want my hair to look like
So the
that.
2023.
Then I would go
You don't want
But
big
it has
hair like
11
the
miles.
People like this is
11 miles.
like this. I feel like they would overdo this so much.
It'd be 30 a month.
Like, I don't want them to do it too much.
Why is it different?
This is if you're in radians. This is if you're in degrees. No, it's the first one. Theta, min, max, and step. And the x you need to leave at negative 10 to 10. Negative 10, min, 10 max. And then hit graph. There you go.
Back engine. Maybe it runs quicker.
Is that the last slide?
Yeah,
I think the next slide that I have up here is in the
That's chill.
homework.
that's chill.
Okay, it's number 16, and it's letting you know, like, heads up, number 16. They give you this gigantic rectangular or polar equation, and they ask you to convert it to rectangular. So in this case, what did I do? Hold on. Oh, I substituted x squared plus y squared in for r squared. Okay, so remember on our formula sheet we said r is this. Look, you might want to write this on your formula sheet or on your notes. But remember this, right?
Maybe long time.
Well, if I square both sides of this, then I get r squared equals this, right? Okay, that's like an extra formula you can use. So instead of having like an r, because I really don't want to come in here and add a square root to this mess, what I did was I multiplied by r. By r. Remember, in equations, you can do whatever you want to one side as long as you do it together. I chose to multiply the whole thing by another r, because that would give me an r squared here, right? And r squared is this, which is way prettier than this. And then that would give me a 7r cosine theta. What is r cosine theta? X. And that would give me 4r sine theta. What's r sine theta? Y. So you can get creative by actually introducing a whole nother r into the equation, and it will actually be easier along the way than trying to plug in the square root of x squared plus y squared into just r. So that is kind of coming back on chapter 7, where you're getting like creative and having to treat it like a puzzle.
I hate puzzles.
Yes.
No.
Yes. Hold on.